So like we just said, a reflection is a flip over a line. Now the first thing that we're going to do is we're going to plot these points on our graph, A, B, and C. We have negative 1, 2, Tamaras. We have negative 1, 2, making sure we label everything. B is negative 1, 5, and C is 2, 7. All right. So the first line that we're going to reflect over is the x-axis. Now, if you have a highlighter, I would take it out because we want to highlight our line of reflection. Or in this case, our line of symmetry, it's also called. We're going to highlight. Oh, it doesn't show up very well. So I'm just going to do this. We're going to highlight our x-axis.
How would you reflect across the y-axis?
We're going to do that next. I know, we're going to do it next. All right. Who knows how we can reflect over the x-axis? What do we do on a graph? There we go. Okay. And then you fold it. So on a graph, yes, you can remember the rules, or when it's on a graph, all that I do is I count along the graph how far each point is away from our line of reflection. So, how far is A away from our line? 2. So, on the other side of the line, I'm going to 2 away, put my new A, my A prime. How far is B away? 5. So, I'm going to count 5 to the other side. How far is C away? So I'm going to count 7 to the other side. And I have now reflected my shape. So where are the coordinates of my new A, my A prime? Negative 1, negative 2. What about B prime? Negative 1, negative 5. What about C prime? 2, negative 7. So, looking purely at the coordinates, what happened here? So the x did what? Stayed the same, and what happened to y? It negated. So this is our algebraic rule for reflecting over the x-axis. And then our geometric notation is going to be actually a lowercase r. Yes. So rotation and reflection start with the same letter, so they had to differentiate. Reflections is lowercase, rotation is uppercase. Little r, x-axis in subnotation. Subscript, there we go. I'm like, this is a subscript. That's all you do. So now we're going to reflect over the y-axis. So I'm going to choose a different color. I'm going to do pink, I guess. So now I'm going to highlight my y-axis. All right, we do the exact same thing as we did before. We are reflecting the original image, so we're still reflecting this top yellow triangle I drew. We count how far each point is away from our line. So how far is A away? So we move 1 to the other side. And now this is a double prime. Tamaraz, where's your notes?
I don't know. That's why I was getting out to find my own number.
But your notebook's not over there?
No.
Okay. How far is B away? 1. And how far is C away? 2. Because we wouldn't want to do 2, because that could be confused with like square, and we're not squaring this here. I know, I'm sorry.
Well, too bad. You have to deal with it.
Any questions on this? So where is our A located? Our new A double prime, where is that? And C, lastly, is located where? What happened here? Yes, X got negated this time and Y stayed the same. It's not that we're making it negative, we're negating, right? So if we're negating -1, it's a double negative, making it a positive. So this is little r y-axis this time. Now last but not least, we have reflection over the line y equals x. All on the same graph. Where is the line y equals x? So it does go through the origin. We know this because when x is 0, what is y? Oh, right? We know x is the same as y. Y equals x. So if x is 0, y is 0. So it goes through the point 0, 0. To figure out the other points, just put in random x's. I'm a math teacher, so I like to go in order. So I just did 0. Now I'm going to do 1. When x is 1, what's y? 1, because y equals x, right? So I plot a point at 1, 1. When x is 2, what is y? When x is 3, what is y? Anytime you do not know where a line should be graphed, plug in random x values. What did I say? I don't know what I said. All right. Then we just connect with a line. Connect the graphs, the points we graphed with a line. Oh no. No, I don't know what I did. Any questions on how we graph that line? Oh, no. We were just graphing the line that we're reflecting over. We were just graphing the line we're reflecting over, okay? Now we're reflecting. Yes. You do need to draw it. It's on your backpack, Tamaraz?
So will this always be the line we use for these ones?
You could be asked to reflect over different lines. All right. Now. Oh. All right. So now that we have the line y equals x graphed, we can now reflect over it. So we just drew the line on the graph. Now we have to reflect over it. Now there are two ways that you can do this. Because this is a perfectly diagonal line, meaning it goes straight through the center of each one of the boxes on the grid, it's perfectly diagonal. Because it is perfectly diagonal, to reflect over it, you can count diagonally. So here, how far is A, the original A, the yellow A, away from the line diagonally? 1 and a half. 1 and a half. Do you need to draw that line? No. But it is 1 and a half away. So we go a half and 1 to the other side. This is now a triple prime. Calm down. I'm going to do 2 more. So how far is B away? Diagonally. 3 diagonally. So I move, oh gosh. So I move 3. That is B, triple prime. And how far is C away? 2 and a half. So I move a half, 1, 2. That is C, triple prime.
Is there an easier way to do that?
Mm-hmm. Oh, God forbid we do fractions. All right. So, where is our A triple prime located? 2, -1. Where is our B triple prime? 5, -1. What about C triple prime? Good. So, what did we do here? Did we just flip X and Y? Is that what we did? Whoops. No, all we did was flip them. We didn't negate anything. So either you can remember the reflection rule, or you can do it on a graph. Any questions on this? Okay, before we start the Khan Academy practice though, I do want to show you one thing. On the last part of the Khan Academy, it is going to ask you to draw the line of reflection. So say I have we'll do this point. So A prime. Then we have this point, B, and this is B prime, and then we have C, right? Oh, gosh. Then we have this point. Okay. So, we're given these 2 triangles, and we're asked, plot the line of reflection. Where is the line of reflection in comparison to the two shapes that we have here? Exactly in the middle, right? We learned that the line of reflection is the middle between each one of these reflected points. or in other words, the midpoint. How do we find midpoint? That's slope.
Isn't it like the endpoint
What do you do with the endpoints? Yeah.
minus endpoint? Or
You add those.
Ah,
and then
yes.
divide by 2?
Yes, add the endpoints, divide by 2. So, basically what you're doing there is you're taking the y distance and the x distance and dividing them in half. So if I'm going from A to A prime, what is my y distance between those two? How much did I go down from A to get to A prime? I went down 4. Now remember, we're trying to find midpoint, so we divide that in half. So what's half of 4?
2.
So to get to my midpoint, I'm only actually going down 2. And then how much did I run to get to A prime? Whoops, I went one more. How much did I run?
4.
What's half of 4?
2.
So my midpoint is right there. So now I need to do it for one other point, because remember, 2 points make a line. So I'm going to do C, I guess. No, I'll do B to make it a little more interesting. How much did I go down to get to my B prime?
8.
8. What's half of 8?
4.
So I actually, to get to my midpoint, I'm only going to go down 4. And then how much should I run? 8 again. So what's half of 8?
4.
So then I just draw my line going through those 2 points, and I have my line of reflection.
Wow.
What was the geometric notation for the last one?
Oh, the geometric notation was just there.
Okay.
Any questions on this?
Are you okay?
All right, so you guys should start your Khan Academy practice.